Hi, this is Juliana Emberson, student number 22034632. I used Packet Tracer to design and simulate the logical composition of this network. The outer layer is the Cardiff University network, the second layer is the cybersecurity sandbox, and my network is working within the second layer. As we can see here, this network is split across 2 rooms and a server closet. I added this IoT door as a visual representation of what I wanted to accomplish with this closet, but was unable to configure it in time. I did leave the right layout, meaning there is an administrative level to the network, which would be the one allowed to monitor and open this door, with the idea of ensuring that untrusted outsiders wouldn't be able to tamper with the physical equipment, avoiding unauthorized access to data, and adding a layer of physical security. The network is split across 2 rooms, the staff and admin room and the students' lab room. The rooms have different physical requirements, which I tackled by having 2 subnets in the staff room and just a singular subnet in the student room. This decision was aimed at the level of trust the network must have according to the particular user related to that subnet. The staff room was focused on offering 2 levels of hierarchy, a totalitarian and absolute one to the administrators and a medium one for the staff, while on the other hand, the students should not be trusted at all with data sent to the internal configuration of the network, placing them with the lowest hierarchy. This essentially allowed for a clear understanding of the permissions to be assigned to the firewall, which filters the network traffic based on the predefined rules for each user. In terms of IP addressing, my focus on the student room was to allow as many wireless devices to connect as possible, hence using a DHCP server to automatically assign IP addresses to constantly changing devices. As we can see here, this is how I set up the DHCP server to do this. Both the staff room and the student room have 40 plus IP addresses designated for PCs and 200 wireless devices. This was done because nowadays wireless devices tend to be more used thanks to their flexibility. There is a detailed Excel spreadsheet where I assigned all these different devices, and it has been uploaded with the rest of the files on my coursework. The main physical component that subnets the network is this writer over here. I did this by allocating a unique IP address at each port and using this address as the default gateway of the devices linked to each particular subnet. So we can see here that the IPv4 address allocated to the admin port is 176.16.10.1, the staff port is 20.1, and the student port is 30.1. They end in 1 because .0 is designated as the subnet network address, the same way that .255 would be the broadcasting network address. I edited the second to last bit portion of the address in increments of 10, which was very easy to understand as I manually configured the devices and also maximizes the number of addresses for each subnet, that being 256 address for each subnet. At the same time, the subnet mask for every device in this network is 255.255.255.0, which made it very simple to configure. Finally, I would like to ping some of the devices to show that they can effectively communicate within the network. Here I am testing the communication between the staff PC and I'm pinging it to a student PC. Here I'm testing the admin PC. I'm also testing the student PC and pinging an admin PC. Just to show that the wireless is also working, I am pinging a student laptop within its wireless network. As we can see here, these 2 devices communicate with no problem.